Have you ever felt privileged to drink a cup of water? Not so often, right? In 2019, World Health Organization reported that 1 out of 3 people didn't have access to clean water. It was 2.2 million people. In order to solve the water crisis problem, water purifiers need to come into the picture as a crucial solution. Because water is usually polluted by ions, heavy metals, and organic substances, the filtering membrane should be able to attract such a wide variety of impurities. Only a few materials can do so. But luckily, there's one coming from a familiar writing tool, your pencil. The material in the core of your pencil is called graphite, and its isolated form is graphene. To use graphene in the filtering membrane, its chemical activity needs to be enhanced. Scientists have found a way to do so by introducing hydrogen and oxygen to this base material and create something called graphene oxide. However, such a modification to graphene makes it more sensitive to damage. I'm Hoang, and today I will introduce you to a way to strengthen graphene oxide and just to maintain its functionality. As my team and I were discussing how to overcome the fragility of graphene oxide, we realized that spreading a layer of polyvinyl alcohol or PVA can solve the problem. For one reason, PVA was safe and affordable because it was usually used for pharmaceutical coating. For another reason, PVA could form an extensive network of hydrogen bonds with graphene oxide. And hydrogen bonds are strong because we know they are responsible for zipping two sides of DNA strands. However, it was only a half of the story because introducing a thick layer of PVA onto GO made it more lubricant. So thickness control is desirable here. So my collaborator from the Department of Material Science came up with the brilliant idea mimicking the way that you make a sandwich. So a slice of geo bread was coated with a thin layer of polymer jam, and then slices were stacked onto each other up to the thickness of the filtering membrane. So the resistance of such a membrane was then tested by a sequence of nanomechanical testing, and we saw a more than threefold increase in terms of resistance compared with like a merely stacked geo. The mechanism was then reviewed by atomistic simulations. When a crack appeared on geomembrane, the PVA chain was then tried to hold two sides of the crack together and prevent further crack growth. So the feasibility of the method encouraged us to discover more on different types of polymers that can do the job. And our ambition is to create or to make affordable and safe water purifiers more accessible to people in need, and that contribute to solve the water crisis. Thank you for your listening.